So now I just came across this old diagram. I thought it'd be a good time to cover it again. In recent videos, we've been looking at the 10 watt 5 ohm resistor right here. So we could put 5 volts across here, and since it's 5 ohms of resistance, that will be 1 amp of current going through it. 5 volts times 1 amp of current equals 5 watts, which is half of 10 watts. Usually you want to stay below half of the maximum wattage rating to make sure not much damage can happen to the resistor. But in any case, this is a 10 watt resistor. This is a 1/4 watt resistor, the standard size that you get in kits and stuff. And I had grabbed it off of the board. It was off to the side, and used it as an example of the size difference right there. That can dissipate the larger one about 40 times as much heat as this little resistor right here. So you do the calculation in wattage. Doesn't matter the size and the resistance and everything. You multiply the voltage across it times the current flowing through it, and you get the wattage. But this can dissipate a lot more power. That's why we can get a lot more current to flow. So we're going to get an idea of the current that can flow through the 220 looking at the numbers right here. So now zooming in, it's kind of hard to see the color on camera of these resistors there, even if I zoom in, and so I put them over there. Of course, we want the brown band to the left, and that magnetic screwdriver is kind of being annoying right there. So yeah, we got red, red, and then black, black. So that's 2, 2, 0, and then this is a multiplier. So that means no more zeros or time 1. 0 for no more zeros. Or there's these beige ones. They usually have a 5% tolerance instead of 1% right there. So it could be about 5% higher or lower than the rated value. But again, 2, 2. Now brown is for 1, but it's in the multiplier spot. So that's 1 more 0, 220 ohms. And you could also look at it as times 10 if it's a brown band there. So 22 times 10 is 220. That's how the color code goes. That's the schematic symbol for a resistor. The rated value, 220 ohms, suggested value you should use if you see that on a schematic. And VCC stands for the positive supply. Negative supply, they're ground, and this is kind of like a current measurement spot. You don't actually have to take it. It's just indicating what you can expect to see on a meter if you measured the positive supply resistor and then inserting the meter into the circuit before connecting to ground. The current has to flow through the meter. So there we can see the current. It's linear. So 220 ohm resistor. If you have 1 volt, you can expect 4.5 milliamps of current to flow through it. You double the voltage, 2 volts, you can expect twice the current, 9.1. So these are rounded off. That's probably spec higher than 4.5. But about 9.1 right there. Again, 3 volts is 3 times as much current as 1 volt. You get about 3 times as much current, and so on. That is linear. That's pretty straightforward. The thing with heat, though, is that is the voltage times the current. So if you double the voltage, you'll get twice the current, and then when you multiply them together, you'll get twice as much, you'll get 4 times as much power right there as a single volt when you whatever you double it from. The original voltage, if you double it, you'll have 4 times the heat that is generated, the wattage. So now, when we looked at the 10 watt resistor right there, we were able to get 5 volts across it, 1 amp of current. So we were able to get 1 amp of current, and that's a large part due to its size. If we had a smaller, a 1/4 watt resistor, we'd have to lower the current to keep the resistor from overheating. But due to that large size, we could get 1 amp of current through it as a 5 ohm resistor. So we'd have to really keep the voltage low if we were using a 1/4 watt resistor that's 5 ohms, but I'm not going to do that math right now. Instead, we're just going to compare it with the 220 ohm resistor, which is used a lot in 5 volt circuits. So if you just put the 5 volts across it, straight across it, you can expect about 22.7 milliamps of current, and which is in the LED lighting range. And there's a bunch of other uses you can use for lower current. But if you're trying to provide current, you could put you know, somewhat significant current. You could put 5 volts across 220 ohm resistor, get to 22.7 milliamps of current. But the wattage is going to be almost 125 milliwatts, just a little bit below that. So if it's a quarter watt, that's 0.25 watt. That's its maximum rated value. You should stay below 0.125, which we do have here. So it'll get, you know, fairly hot, but you won't want to touch that. But, you know, you shouldn't fry the component if it's exposed to room temperature air. And any case, that is what you can expect with 5 volts across it. Now, of course, if before you have the current or after, where you measure the current, doesn't matter if they're in series, what their positioning is when it comes to how much current will flow through them. If you have an LED that's forward biased, if you put it in backwards, it's not going to let any current flow through. But as long as it's forward biased, with a red LED, you can expect the red LED to drop 2 volts. So there'll be 3 volts across the resistor. This is usually what we see when I have my 5 volt circuits with the red LED protected by a 220 ohm resistor. We get about 13.6 milliamps of current flowing through it. Now the resistor is not getting terribly hot. So we could use like a 150 ohm resistor to get more current through the red LED, make it brighter, but usually 13.6 volts is plenty bright. Now, when it comes to the blue LED, so we're using 5 volts at the supply, but the blue LED drops about 3 volts. So we drop down to 2 volts across the current setting resistor when there's a forward biased blue LED in there. And then you could get 9.1 milliamps of current going through that circuit. Again, the resistor not getting very hot at all. But you know, we could use a lower value resistor to get more current through a blue LED, but it's definitely really bright at 9.1 milliamps of current. Usually I use a 1000 ohm resistor to get about a fourth of what you see here. You know, about 2 and a little bit more than that. But in any case, that is the way it works when it comes to the voltage or the current going through the resistor. It's whatever the voltage is across it. So even though the supply voltage is 5 volts, if other stuff is dropping voltage, you got to subtract those drops, and that will be the voltage across the resistor. 220 ohm, that's all we're thinking about on this chart. That'll be the current that goes through, if there's a blue LED in series in this case, and the wattage that will be produced. But the main takeaway is, there you can see, with this resistor here, a quarter watt resistor, we can get about 22.7 milliamps of current. Of course, it'd be better to compare with a 5 ohm resistor of this size, but there you can see the difference.